I'm in the process of testing the tubes of the Motorola 5D13P Quasar, and right now I'm testing a tube of the type 35W4. Now honestly, I've never seen a tube like this, but I'm not quite sure, but I think it might be a diode or rectifier, in other words. In any case, let's just have a look. I won't bore you with testing all the tubes one by one, but once I've tested this one, I'll test all the others, and I'll be back with another update. So let's have a look at this one, shall we? So I insert the tube into the right socket, which is this one. Then I have a look at the specifications, and it says 35W4, set the filament to F. And yeah, the filament is set on F. Then it says set the type to triangle. That's correct. Then it says set the socket to 3. We did that. Then the selector to 5. But I don't need to bother with the selector at first, because we need to check it for shorts first. So the only thing I need to set now is the filament, which is or the sensitivity rather, which is 35. Yeah, that's set alright. Okay, so first we need to test it for short. So I set the switch to short, and now I switch it on. I put the selector to 1. Oh yeah, and they say I need to disregard position 4 and 6. Okay, so let's switch it on. There you go. Let's see if the filament burns. Yes, we have filament. Okay, that's a good sign. So now let's see whether we have short. So let's just watch this indicator light. So 1, 2, 3, 4 lights on, but they said to disregard it. 5, 6 is on, but we disregard that one too. 7, 8, 9, TC. Okay, so basically this tube has no shorts whatsoever. Fine. Now let's check the quality of it, or the emissions. So I set the selector to 5. Yep, there you go. It's on position 5. Okay, so now I throw the switch on to regular. Okay, now let's see. Great. So this 35W4 tests really far in the good. So this tube is okay. Well, it seems we're foiled again. This is a 12 AV6 triode, and as you can see, there's absolutely no silver in it. There's no gather, no nothing. So I already had a very bad feeling about this tube. So I suspected it might be gassy, or at least leaky. So I put it into the tester, and the moment I switched on the tester to test it for shorts, I saw a very short bright flash. In other words, the filament burned through. So, but okay, it's bothering me a little bit. But on the other hand, when I saw the tube, I already knew that there was a problem with it, and effectively, it turns out the tube is gassy. Well, I should say was gassy. Now, the point is that since this tube is bad, and I need it to make the Motorola function, well, we're foiled again. I mean, I can refurbish the radio, but I don't have a spare 12 AV6 lying about. So unfortunately, once again, we'll have to wait until I get a replacement tube. So I'm sorry guys, but you'll have to exercise a little patience like I will have to. Now, the other tubes all tested good, except one which tested a little bit weaker, but was in fact a good tube. So there you are. You'll have to show a little more patience until I get a replacement for this 12 AV6. Okay, so, I'm gearing up to clean and change all the parts on this Motorola 5T13P chassis. I disconnected the speaker and the antenna leads from the chassis because, well, for convenience sake. If it were still attached to the speaker or to the antenna coil, it would not be nearly as handy to work on as it is now. Now I can turn it over left, right, up and down and work on it at my convenience. So the first thing I'll do is clean up everything, and then I'll start changing all the capacitors. I'll also probably end up measuring the resistors just to see if they are still within spec. If they are not, then I'll probably end up changing the resistors too. Now, there are two parts on this chassis that will cause me a little bit of a problem, which is this on-off volume button, which is rather unusual in shape and in size. So yeah, well, this part might cause me some trouble, and eventually I'll have to change this electrolytic too. It's a combined electrolytic, meaning that there are several electrolytics in it. Now that isn't going to cause me a problem, but what is going to give me some headache is to open up this can and fit in 3 modern electrolytics inside. As you can see, the can is rather small. It's about a thumb high and half a thumb wide. So it's going to be causing me not a slight headache as to how I'm going to change the electrolytics inside. Anyway, let's start with the beginning, and let's start changing all the capacitors and measuring the resistors, and of course cleaning it, because there is some muck and some dust and everything on this Motorola radio chassis. I decided, after I noticed that the values were quite off, that it wouldn't pay off, in my opinion, to leave most of the original capacitors on the PCB. And so, against my initial wish of keeping it as original as possible, I decided to, to replace all of the capacitors, at least. Also, I will have to probably change this power resistor you see here near the electrolytic can. It measures off by about 170 ohms. It's rated at 1200 ohms, 3 watts. Or 2 watts, sorry, 2 watts. I'll have to consider changing it because, well, it's off by quite a bit, although still within tolerance, but I don't trust it. Okay, anyway, before I continue work on the chassis, I want to draw your attention to the fact that the PCB is actually double-sided, as you can see. So there is copper traces on the lower side or on the bottom side, but they are mirrored by copper traces on the top side, which is, all things considered, quite modern actually, and it's very efficient, since if you would have to make connections to between all the parts, and you would have to use only one side, then the traces would be either much more complicated and much longer, or the board would have to be much larger to accommodate all the interconnections between all the parts. So actually using a double-sided PCB is actually quite clever. It's making the most use of very little space. And as you can see, the chassis of this Motorola radio is really very small, comparatively speaking. Oh, by the way, there is a crack in the oscillator coil insulation, I hope you can see it, but right at my fingertip the insulation is cracked. Now, I don't think that's a big problem, but I might have to repair that a little bit. It feels waxy, the surface, so maybe if I'm lucky, with a short blast of the heat gun, I can remelt the wax a little bit and make it one coherent part again. Anyway, it's a detail, but an important detail nonetheless, because if they put coating over the oscillator coil, that certainly has a reason. So, in my opinion, it would be best if I repair the crack too. Oh, and to my astonishment, I noticed that the on-off actually does work. As you can see, this is a rotary potentiometer for the volume, but I was wondering why it didn't click in either direction to switch the radio on or off. And then I realized that maybe I would have to push, which I tried. Didn't work. So then I finally said, okay, maybe I have to pull. And what do you know? It does work like that. So when you pull it out, you switch the radio on, I imagine, and when you push it back, you switch it off. So, yeah, my mistake. I thought it was a rotary on-off switch, and it turns out to be a push on-off. Arguably, the yellow capacitors are not as good looking as the original brown reddish ones that were mounted inside or on the chassis. But well, they are 50. The original ones are 50 nanofarads, 400 volts, and the only capacitors I had on hand that were close to that value were these yellow ones of an unknown brand of 47 nanofarad, 630 volts. So when you change capacitors, well, you should always use, of course, capacitors rated for the same voltage or higher. And as it's about the same shape, I thought I would just use these yellow ones. So sorry for the purists out there, but well, in this case, safety before beauty. Okay, I changed all the capacitors, well, all the ceramic capacitors on the chassis, and as you can see, it went rather well. And now I'm stuck a little bit with the last hard thing, which is to unmount this electrolytic can. It's attached by 3 points down here on the PCB, as you can see, at 3 points here and there and there. And then the electrolytics themselves are also soldered. So I already used a solder pump to remove most of the solder, but detaching the can completely from the PCB without breaking it, well, that will ask some patience and some perseverance. Anyway, one of my subscribers, Bobby Tektelabis, warned me about the fact that the traces on these PCB boards were infamous for being very brittle and easily breaking and lifting off the PCB, probably when heated too much or when there was or there is too much mechanical stress exerted on them. And until now, as I was changing all the capacitors, for example, and a few of the resistors, everything went well. But in the end, unmounting this electrolytic can or capacitor can proved too much for the poor traces on this PCB. As you can see here and here and here, the traces were obviously no match for the forces involved in attaching this electrolytic to the PCB. And well, it was really a story waiting to happen. As you can see, this electrolytic can sports 6 very heavy lugs, which were soldered on either side of the PCB, and to boot with a lot of solder. So I really had to take away a lot of solder to be able to pull this electrolytic can off the circuit. So okay, there is a little bit of damage, but it's in non-essential places, and I managed to repair the traces that were lifted up, namely this one and this one, by using a little bit, a tiny little drop of regular super glue. So although there is a little bit of damage, it's really not too bad. And in the end, since I will remount this can once I stuffed it with all the necessary capacitors, this damage will be hidden in the end. It's a pity, of course, and I really try to be very careful while trying to unmount this can. Now, I know some of you will probably say, well, why didn't you just cut the can open with a little metal grinder or something like that? Well, yes, I could have done that, but that would have damaged this can. And this is the original Motorola can, as you can see. And since the can is visible from all sides, but the traces underneath the can aren't, I elected to remove the can, knowing that I might cause some damage to the traces. So there you are. On the other side, the damage is really minimal. In fact, there is no damage at all, as you can see. The reason why there was this much damage on top is that it was very hard to reach the contacts or the lugs from between the PCB and the electrolytic can. So anyway, that's it. A little bit of damage, but I did manage to get out the electrolytic can. Now, there is a funny little detail I would like to show you. I don't know if you can see this, but let me see if I can zoom in a little bit. Hang on. As you can see on this can, the capacitances, there are 3 electrolytics inside this can. And next to the capacitance is a little symbol. You see here a square, a triangle, and just a simple little stripe or hyphen. The hyphen is the 30 microfarad, and the triangle and the square are the 40 microfarad values. Now, if you take a look at the bottom of this capacitor, and if I can focus the camera, hang on, you will see, for example, at the top of this lug, there is a triangular opening. If you look at the next lug, you see there's a square opening above it. And at the third lug, there's nothing at all. So, in fact, with these little symbols on the can itself, the square, the triangle, and the hyphen, and these cutouts in the bottom of the electrolytic, they managed to indicate where which capacitance was located, or rather which lug to use to connect to which capacitor. Very nifty. Also, it's a very nice can. It's really nicely made and solid, very solid, as these poor traces proved. Now that the can is out of the circuit and I look at it from the side, I can see there's a slight bulge here, precisely here, where I put my finger, in the wall of the electrolytic. And this tells me that the electrolytic probably at a certain stage short-circuited and blew. So I wouldn't be astonished that this radio at a certain point, while they were using it or listening to it, it suddenly gave out, and all the fuses in the house must have blown at the same time. So I think I didn't take the wrong decision to unmount the electrolytic can, because I think that inside I will find probably a burned mass. So anyway, what I'm going to try to do is to uncrimp this lower edge of the electrolytic can so that I can lift out this little, I don't know, plastic cover, I think, and then pull out the electrolytics inside. At least that's the plan. Well, there we are. I managed to extract the capacitors out of the electrolytic can, and it appears to be just one giant roll of paper or cardboard and aluminum rolled together. I would tend to say this is a classical kind of electrolytic. It feels slightly greasy, so I wouldn't be astonished if there's some kind of mineral oil impregnated into the cardboard or paper. Also, it turns out that the roll was attached inside the can with, well, either black tar or a sort of wax. So I will need to clean out the bottom of the can with something with maybe thinner or something like that. And oh yeah, I did manage to uncrimp the edge, the lower edge of the can, as you can see. And in fact, this ring you see here with the 3 lugs which attach the can to the PCB sat on top of this tiny little, well, I don't know if it's plastic, but it's certainly some kind of polymer, and it sat on top of it, and the edge of the can was crimped right on the edge of this ring. So this ring sat in, effectively sat under the edge, the crimped down edge of this can. So I sort of gently pried up the edge of the electrolytic can with the flat of a small screwdriver by pushing it under the edge and then rotating the screwdriver a little bit. And I did that all around the can, and I did that for several passes, so maybe 5 or 6 passes, because I didn't want to force the can open in one go. So I gently pried up the edge more and more and more until it nearly stood straight up. At that stage, I took a needle nose plier, like this one, and I started to gently bend the edge straight up, as you can see. So I think I've managed to keep the damage to the electrolytic can to a minimum. So there you are. This is the inside. And this is the can itself. It will clean up quite nicely once I'm done with it. It's aluminum, and well, I think I can reuse the little cover that was originally on top of the electrolytics like this, and by rotating it, by using the inner side, well, as you can see, this is really clean and nice. I can put it back on top of the electrolytic like this, and one would never imagine that, if I do it right, of course, that this can was ever opened. So yeah, there you are. I will need to find the right capacitors which fit inside this can, because it's really rather small. Let me see. The can measures from top to bottom. Let's see. It measures from top to bottom 5.7, 5.8 centimeters, and its diameter, its inside diameter is, let's see, about 2.5 centimeters. So yeah, it'll be quite a deal to find capacitors which fit inside this can and perform the job that is needed. Excuse me, I need two 40 microfarad 150 volts rated capacitors and one 30 microfarad. Now I ordered a few capacitors, but they didn't sell 40 microfarad, but they sold 47, and instead of 30 microfarad they sold 33 microfarad, which is close enough. So and they were rated for 250 volts, not 150. So I'm not too worried about the specifications, the electronic specifications of the capacitors, but rather of their physical sizes and properties. So well, bear with me, and once I have all the parts needed to finish the restoration of the Motorola, I'll be back with one more, and hopefully the final update on the restoration of this radio. And then, if we're lucky, we might even hear it play. So stay tuned, guys. Thanks for watching.